Okay, hello everyone, and let's get started. So I continue my series of videos related to cloud technologies, and today we will talk about core concept of any cloud platform. It's virtualization. Yeah? So if you haven't seen the previous video when we talked about comparison between on-premise and cloud, what are the disadvantages of using on-premise servers or on-premise infrastructure if you compare it to cloud. I would suggest to watch it right now. So the link on that video should appear on the right top corner. Yeah. Other than that, let's proceed. So today we'll talk about what virtualization actually is, what are the types of virtualization available right now. Yeah, so based on that, we will define what cloud actually is. Yeah, and after that, we'll compare or differentiate cloud and self-hosted VMs. Yeah, so what are the differences? Yeah. Also, don't forget to visit my website available at dataguru.guide, where you can find some additional materials. For example, this presentation is available for download there. Also, some interesting articles available there as well, related to cloud, big data technologies, Java programming language. So just take a look. Okay, so let's talk about virtualization. Yeah, so on the left, we can see a representation of a traditional server. Yeah, so we have some hardware, CPU, memory, storage, and so on. So we have an operating system installed on that server, and we have one or multiple applications running on that server. Yeah, so one server, one operating system and multiple applications running on that. Yeah, so that's the traditional computational model with one server with one operating system. Yeah. Um, so the next step towards virtualization was done. Then we have one server, but on top of host operating system. Yeah, so operating system installed on the hardware is called host operating system. Yeah, on top of host operating system, we install special software called hypervisor. Yeah, which allows us to emulate some hardware resources available to um, to a special um, operating system instances called VM or virtual machine. Yeah, so hypervisor, so it's a buffer between a physical hardware available, so the physical metal server, and guest operating systems. Yeah, so operating system installed inside virtual machine is called a guest operating system. Yeah, so hypervisor, it's a buffer or bridge between host operating system and hardware available and guest operating system. Yeah, so hypervisor emulates some subset of hardware available in the server for the guest operating system, so that guest operating system, so this operating system doesn't even notice that it runs in a virtual machine. Yeah, so that the resources like CPU, memory, storage is not the actual ones, but are just emulated. Yeah, and that gives us a number of benefits. Yeah, so for example, we have a server, but using virtual machine approach, yeah, we can install multiple operating system on that server and make them run at the same time. Yeah, so because, for example, we need uh, to run some programs or applications which are available only for Linux, for example, and some applications which are available only for Windows. Yeah, so what to do? Should we have two servers? No, if we use virtualization approach and just create two virtual machine. On one virtual machine, we will run a Linux operating system, and on another one, uh, respectively, Windows operating system. And this virtual machine is completely isolated from another virtual machines available Yeah, so they even don't know about each other. Yeah, if you specifically don't do some actions like opening ports, connecting from one to another, and so on. Yeah, so that's a completely isolated environment. Yeah, so that's what a virtual machine is. Yeah, and recently we have made a next step towards even more abstraction. Yeah, so that's the virtual machine concept we talked about in the previous slide. And then we made a next step and moved from virtual machine to containers environment. And the idea there is very simple. So we don't virtualize hardware like we did here, but we virtualize operating system. Yeah, so the downside of using virtual machine is that virtual machine should contain operating system, all files and so on. Yeah, but let's say these two, both operating systems are the same. Let's say it's Ubuntu. Yeah, so we waste a lot of resources in terms of storage, CPU, RAM to make this run because operating system behind these applications here and here, it's the same. Yeah, but still they are isolated, so we need to provide operating system in this virtual machine and in this as well. So the typical size of virtual machine is gigabytes, yeah, tens of gigabytes, and so on. And it of course takes some time to boot, and it takes significant amount of resources. Yeah, so the idea behind container is quite simple. Why should we share this? Why should we ship operating system with each virtual machine? Why don't we use uh, shared operating system and only provide libraries and some dependencies, configuration files, which are specific to this application? Yeah, because this and this application can run on the same OS. So why should we put OS here, here, and here? No, let's make it share among all containers and just provide some libraries, other dependencies or configuration files which differ between these applications. Yeah, and one of the services which allows us to create containers and run containers is Docker. Yeah, so that's what we will talk about when we talk about AWS. Yeah, because Docker and container service is highly utilized there. Yeah, so that's what a container actually is, right? What are the advantages of containers over virtual machines? So containers, since they share operating system, so we don't need to include operating system inside the container. Yeah, so that's why containers are quite small. Yeah, so tens of megabytes, or if we have a big application, it could be hundreds of megabytes, but not gigabytes or 10 of gigabytes like virtual machines, meaning that containers start very fast, yeah, in couple of seconds typically, or even immediately, almost immediately. Yeah, so they don't need so many computational resources like CPU and memory, like virtual machines. Yeah, so that's why containers are the way to move forward if you can. Yeah, because there are some issues related to containers as well. Yeah, since you see containers share the same operating system, there might be some security related problems because this operating system is not isolated. It's a shared among all containers, as you can see. So here, operating system is isolated and dedicated only to this particular virtual machine. Yeah. So in that terms, virtual machines are more secured than containers. And another thing why we can't immediately migrate everything to container is that we have a lot of tons of applications, legacy applications, which are not designed to be run in containers. Yeah, so we need to allow some time to migrate from traditional servers or virtual machines to containers. Yeah, so in the next 10 or 20 years, we'll still use virtual machines. Yeah, but the most new development is done in containers, not in virtual machines. Yeah, so when we'll talk about Amazon Web Services, we'll start talking about virtual machines or EC2, like it's called in AWS, and then we will gracefully move to containers environment. Yeah? Okay, so based on that, what we have discussed about virtualization, let's now define what the cloud actually is. Yeah, so the cloud could be defined as a set of scalable, on-demand, virtualized resources, right? So they are scalable. So based on demand, we can shrink uh, or scale them, yeah, depending on what we need. So that's on demand, yeah. So when we need, we shrink. When we need, we scale. Yeah? And they are virtualized. So virtual machines or containers are behind the cloud resources. Yeah. So we use containers, we use virtual machines, or we use services, like we will talk in the next couple of slides and videos. So, but all these are virtualized. Yeah. So, and cloud provide us computation resources, so like virtual machines or containers, also storage. Yeah. So we can store our data securely, durably, redundantly. So storage, that's also one of the services provided by any cloud platform. Networking. So if we want to make our a virtual machine or container communicate with each other or internet, we will need some networking, and also some other services like applications which we do not manage or host. They are hosted by cloud provider. We are just using them. Yeah? And a very important thing that these resources are almost unlimited. Yeah? If we take a cloud provider like Amazon, Azure, so it's highly unlikely that you will hit the cloud limit and you will not be able to request more resources because they don't have any. Yeah? And based on that, let's talk about differences. Yeah, so the one can say, okay, cloud is a virtualized, scalable on-demand resources, but why can't I host virtual machines on my own PC or server? Yeah, so what's the difference? Yeah, so let's look at that. So self-hosted VM resources. Yeah, so we have some virtual machines created on our own server. So and this virtual machine uses some resources like CPU, memory, storage, and these resources are limited to physical server resource capacity. Yeah, so we have a virtual machine running on your server, and obviously the resources available to this virtual machine are limited by server resources. Yeah, so if your server has, for example, 64 gigs of RAM, you can't assign 128 gigs of RAM to your virtual machine because your server doesn't have such. Yeah, but that's not the case for cloud because, as you remember, we defined cloud as a scalable, on-demand, virtualized resources. So if you need more, so I have 64, I need more, you can easily resize your virtual machine, and that's the benefit of cloud. And another thing about self-hosted VM, so if some of the resources of your physical server are not used, you still have paid for them. So you bought a server, so you paid for that. And now, if you don't fully use your server, you still have paid for that resources. Yeah, but for cloud model, so it's on demand. So you pay only for what you need or what you use. Yeah, so let's compare to cloud. So cloud resources are virtually unlimited. So you are only limited by your budget. So how much money you can spend on cloud resources. So that's basically the only limit you can hit. And another super advantage of the cloud, you only pay for the resources you are actually using. Yeah, you can scale and shrink used resources based on your needs or budget. Yeah, so if you don't need 64 gigs of RAM, you can shrink your virtual machine and use only 16 gigs of RAM and pay only for 16 gigs of RAM, not for 64. Yeah, so the same applies to storage capacity and for CPU as well. Yeah, so you pay only for what you need or what you use. And besides raw resources like virtual machines and containers, cloud providers offer applications and services running in the cloud, which are hosted, managed, patched by the cloud itself, cloud provider itself, so you don't need to worry about that. So that's a short overview about virtualization, what actually cloud is, yeah, what is the difference between self-hosted VM and VM hosted in the cloud. Yeah. So that actually concludes our introduction to virtualization and cloud as such. In the next lecture, we will finally start working with AWS, yeah, and we will start by creating a new account and looking around. Okay, so for today, that would be all from my side. If still you have some questions, comments, suggestions, don't hesitate, just write them under the video. So if you like that video, you can also press like. Don't forget to subscribe to this YouTube channel if you haven't done that yet. So besides cloud topic, we will discuss more things related to big data technologies and to Java programming. So if you are interested in that, subscribe. Also, don't forget once again, visit my website, dataguru.guide, where you can find some interesting posts. Okay, other than that, thanks to all for watching and see you next time. Bye bye.